This is ARM's Mbed IDE and online compiler. I'm going to bring you through the main functions involved with implementing Bluetooth, the accelerometer and magnetometer. So in the main .cpp we have the device name, which you saw on the BLE scanner app, and the list of unique identifiers for each device involved. So down in the main function we have this periodic callback. So in the main function of the periodic callback being called, which basically then in turn calls the polling functions for each device. So if we go over to the accelerometer, we see the, as we saw with the logic analyzer, we can see the I2C address here, and then there's other characteristics like the unique identifiers. Then we are going to configure the accelerometer by writing to the control register addressed here. Then we go down to the main function that runs, which is the polling function, and this is running the I2C read as described before, and retrieving 2 bytes per axis, the x-axis, y-axis and z-axis, and this data is advertised across Bluetooth. So if we go over to the mag service, which has a bit more content in it, again I2C address, so we're addressing the unique identifier. Then we are configuring the magnetometer by addressing 2 different control registers. So control register 2, we are enabling auto resets on it, and then control register 1, we are activating the magnetometer. So again, the polling function is the main function being used here, and this one's slightly different. I've changed it so that I'm first reading the status register addressed here, which contains the X, Y, and Z data from the magnetometer. Contains the X, Y, Z data ready bit, which is part of the status register, and this bit only contains a 1 if the data on any of the axes has changed. So if we go down to this if statement, we can see that the third bit in, so we're writing to the reading from the status register, and then we bit mask, and with a bit shifted over 3 places. So basically what this statement is saying is only if the XYZ data ready, which is bit 3 in the status register, is active, then the registers should be polled and updated. So this basically just saves running through all of this code every time if, say if the magnetometer is not moving at all and the magnetic fields aren't changing. So hopefully that's some optimization. And those are the main changes I made to the program, and it runs quite well.